Hello, in this video we're going to go through Learning Target 633, and this is part 2. So in part 1 we talked about addition, subtraction, multiplication of different functions, and it was basically a review of our polynomials unit. We've done all those operations before. These ones are new though, and these are like true composites where you compose one function into another. Basically meaning you plug an entire function into another. This is exactly the same as substitution when we did our systems of equations. It's just in a different notation. And so here are the notations you're going to need to know. One looks like this, where this is pronounced f of g of x. If you want to write that down, it's f of g of x. And what that means is that you want to plug the inside function into the outside one. So in this case, it would be g into f. G is on the inside, so I would take g and I'd plug it into f. The x doesn't matter because, again, that's just telling us what variable we're using. So I take g, I put it into f. If it was g of f of x, you would take f and plug it into g. So whatever's on the inside, you plug it into the outside. This notation is the most common, but this one that looks like it says fog is the exact same thing. So this is the same as that, and you would want to plug in the second one into the first. So this little open dot basically just means compose. And so in this case, again, it would be g into f. So same way, it just doesn't have all the parentheses. This one, the only difference is that a is a number. And what I think is easiest is to find g of a and then plug that into f. So it's like doing it in 2 steps instead of doing it in 1. And I'll show you that when we do an example, but I definitely think that's the way to go. Order for this one is incredibly important. It's always important, but for this one specifically, it is the most important thing that you need to remember is order. So I want to make sure you write this sentence down. Composites start with the outside and move inward. So like when you're reading it, it's f of g of x, starts from the outside, moves inward. It's really important that you have the order correct when you are doing these. So if you need to pause it to get any of these down, please do so. Let's go through some examples. So this says, given these functions, complete the following operations. The first one is f of g of x. So this means I'm going to take g and I'm going to plug it into f. And sometimes I do that little arrow so I can see myself that I'm going to take g and plug it into f. So what that means is you start writing f. So again, I'm going to color code this so you can see it. This one is going to be purple and this one's going to be blue. And I'm taking my g and plugging it into f. So you're basically taking this entire equation and plugging it in wherever you see an x in the other equation. So for ours, we have a 3. Then an x, so in parentheses is the entire blue function, 4x squared minus 2x plus 10. And then minus 1. So you can see this should mirror the outside one. So f is on the outside, this is f. It should look exactly the same, except x is the only thing that should be different. Everything else should be the same. X got replaced, and so that's what it should look like. And then you're just going to follow your PEMDAS steps from there. So we are going to do our distribution here. So we get 12x squared. 3 times negative 2 is minus 6x. And 3 times 10 is plus 30. Then I have a minus 1 at the end. So I'm going to check for any like terms, which I do have, and I want to combine those, make sure this is in order. And here is our answer. So the important thing with composites is like you just have to practice what these mean. So this means I took G and I put it into F. G is on the inside. I take that and I put it into the outside. G into F. If it was backwards, you would have taken the purple one and plugged it in here and here because there's two X's. So that's one type where you take an entire equation, you plug it into the other equation, and you simplify. It's the exact same thing as substitution, just with function notation. Now this one is a little bit different. This is the one that I said to do 2 steps in. And I like to just work inside out. So f of 3 is something I can really easily find. I guess I should have used purple for that. So f of 3 means to plug in 3 for my f function. And that gives me 8. So 9 minus 1 gives me 8. And then I'm going to take that and plug it into G. And so G of 8, I have 2 spots to plug it in. And then I want to type this into my calculator. So I think it's better to find f of 3, figure out what that is, because f of 3 is just a number, and that number is 8. So find f of 3 first, then take that and plug it into G. So let's figure out what that's going to be. We get 250. In theory, you could also set it up where you plug in 3 for F and then you plug in F into G. It just looks really, really complicated. So let me show you like what it would look like. If I wanted to plug it in, so G of F of 3 would mean take F and put it into G. So I would have 4, then parentheses, 3x minus 1 squared minus 2 times 3x minus 1 plus 10. And then I need to plug in that 3 still. So I have this craziness. Oops, sorry. So this is like the insane thing that you would need to do if you wanted to plug it all in at once. And then you could type this into your calculator and you'll get the exact same thing. But personally, I think what we did was much easier, just finding f of 3 first and then plugging in that number to G. But you could do it this way as well. I hope this helps with your understanding of composites.